of Cloud Computing and Data Science Lab. Good evening to everyone present over here. Okay. So, before starting the session, let's discuss few questions, and these questions are related to yesterday's class, right? So, we have studied so many things yesterday. So, related to that, I want to ask few questions, very simple questions, right? So, first question, everyone try to answer. How can we find, just I'm writing the question in the chat box. How can we find sample data set, data sets in R? It's the first question, that how can we find sample data sets in R? Those who know the answer, please write in the comment box. It's not for the console only. Sylvester, it's not for only the console. If you write data function in the code editor or script editor also, you can also get the output, right? So two panel we can use for writing the input, writing the code or getting the output. So if you write, yes, yes. If we write data function in the code editor and we'll just select that and we'll click on run, so it will give the entire data sets, sample data sets present in R Studio already in built, that will be displayed in the code editor, right? And the second thing is, if you write at the in the console panel the data function, then it will also display the sample data sets present in the code editor section. Okay, so in both cases you can write either in the code editor section or in the console section. Yes, very good. Yeah, within the data function, if you are mentioning something, that means that is the data set you need. Okay, so whether if you write only data within bracket cars and you will select that and click on run. I am telling in case of code editor, if you are writing in code editor, the same code, if you are writing in the code editor. So after writing this code, if the entire means cars data set will be displayed. Did you get my question? If in the code editor you are writing data function and within the bracket you are writing cars, the example you have written, I am just asking upon that. So if you write this data within bracket cars in the code editor section and you are just selecting the entire thing and click on run, so whether you will get the cars data set. Have you run this? You are not properly audible. I don't know what is the problem. I have full volume here. Please check at your end. Okay. Okay. Sure. Okay. Second question is, that means suppose I want to find, suppose I have displayed the sample data set of anyone. Let I want to display the sample data set of CO2 or iris that we had taken example yesterday. So how can I find the structure of the sample data set? Okay, suppose you have displayed the cards data set, all the variables, all the observations you have considered. Okay, so how can we find the structure of that cars data set? What is the command used? I'm just asking that. Okay, can you say the command? Yes, please write in the comment box. Now you are not audible properly. I can't hear you. I want to find, everyone please try to answer that if I want to find the structure of a particular database, a data set, not database, data set, which command I can use in case of R Studio. Okay. No issue. That is the command is str, right? This is str function. Str. Uh, No, no. I want the structure. You have written that is let you have written that is iris dollar dash. That means from this Sylvester you have written something, and by your the thing that you have written, according to that you will just find out the distance variable from the iris data set. Okay, only one variable you can access the same command you have written, but yes, you understood, right? So using str function, using str command, you can find the structure of the entire data set. That means it will show you how many variables are used. That means how many columns are used, what are the number of observation, and for each column, what is the data type, right? So if you are using character type, or if you are using the numbers variable, or you are using the integer variables, everything will be displayed along with the number of variables and the number of observation. So this is the work of the str function. Okay. Okay, everyone joined. Right. Very good. So let's share my screen and start our session, today's lecture. So all the things that we are discussing about few questions that are related to the yesterday's class, right? So let's share the screen. I'm sharing the screen here. Okay. The screen is visible to everyone. Okay.
Yes, Ma.
Okay. See. So just everyone, just open your R Studio. Please open your R Studio. Okay. So yesterday we are discussing something, and at that time I told you that you attach the data set, and after that you store the entire. That means if you want to find out the value stored at against a particular variable, you can store that in a table also, right? So we'll start from that. If you are opening the R Studio, either you can get this kind of interface, or if you have already opened that, you have already worked out upon the R Studio, you will get this kind of interface like new file, then click on R script. Okay. So this kind of interface you will have. Click on the console panel and click on Control L to clear the console, right? So now it is visible as four panels. As you know that this is a code editor, this is console panel, and this is your environment section, history section, this is the plotting or package section. Okay, the screen is properly visible, right? Next, see what can we do. We will take a particular data set and will perform various operation. Also we'll see how the correlation acts, right? So in the theory section I have already discussed what is the meaning of correlation. That means it is a relationship between the variables. So if you are taking a number of variables, you can see the how the variables correlate with each other. That means positively they are associated with each other, or negatively associated, or within the variables there are no association. So the type of correlation and the value of the correlation coefficient we can also find out through this R Studio and R programming language. So gradually, or we will discuss one by one. Okay, so today only we will read the correlation. How can we find the correlation? How can we find the correlation coefficient using R Studio? So all of you open R Studio and add the console part. Come to the console panel. Here type, let I want to take any data set. So first of all I will type data function that I was asking right now. Data function, then click on enter. So when you will click on enter, you will get number of data sets present. These are the sample data sets and these are the description about the data sets. What is there in the data set? So I'm interested in empty cars, right? So yesterday we are discussing upon that empty cars data set. Let me search that it is present or not. Uh, Empty cars. Yes, it is present, right? This is empty cars, each a data sample data set, right? So what will I do here? So I will type data function. Within that, I will write empty cars. Okay. Then click on enter. After that, I will write empty cars, then click on enter, right? So here you can see that in the environment section, it is written as empty cars. This is the data set. It has 11 variables with 32 observation. You can also see from here, this is the details of the empty cars dataset. These are the variables MPG, CYL, display, HP. These are the variables, right? So here 11 variables are there and total 32 observation if you count them. Okay, so that means we just received the data set empty cars and its value. So what will I do now? I want to find the structure of the empty cars data set, right? So all of you type str function. Within that, you have to write the data set whose structure you want to view. So that is empty cars. So it is displaying, that means it is prompting you automatically. So click on that. Okay, str. Then click on enter. So when you will click, you can see that the structure of empty cars data set is being displayed. So here with the dollar symbol, these are what? These are the variables written, and these are the observations against the variable. That means the values already present against the variables, and these are what? That means in the first variable, the values are of a number type. The second variable, the values are of a number type. That means the entire structure is being displayed here. Okay, so this is what? This is the structure of empty cars data set, right? So are you all getting the same? Okay, okay. If you feel any kind of difficulty at any point, please ask me. So up to this clear. Okay. So str command will do what? It is used to display the internal structure of object. So what is object here? The thing that is written inside the parenthesis is called object. That means we want to find the structure of empty cars. So empty cars is what? It is a data set. That means for our studio, for our programming language, this is an object of which you want to find the structure, right? So then next is you can see uh, here uh, what you can see that telling about the CYL, that means cylinder, this column or variable, that you can see that few cars have cylinder 6, few cars have cylinder 4, few cars have cylinder 8. That means these are what? These are the observation against the columns, right? So what will you do? That let I am storing the value. Let I'm writing her table, then within bracket I will write CYL. Okay, same mistake I'm doing here. I've not attached. Okay, attach, attach. Okay, the data set was empty cars. Okay, then you can see my table is equal table. Okay, so now it is okay. So yesterday this was the mistake that I have not attached this data set, so that's why it was showing me the error that object CYL is not found. Okay, so first of all you attach the data set with the R Studio, then it will be okay for you. So what am I doing in this statement? That my table is what? It is a variable that will store the value of a cylinder variable. Okay, cylinder CYL is a variable or is a column that is present in empty cast data set. I want to store the values present against this CYL column in a tabular format. So for that, I'm writing the command as a table. So this will be fixed, and the table will store what? The table will store the values present in CYL variable, and the data will be stored in the variable my table, right? So then I want to do what? I want to view that whether the data against the CYL is stored in my table or not. So I will write what? I will write v in the capital letter view, and here you write my table. Okay, my table is already prompting you. Here click on enter. Okay, so whenever you will click on enter, you can see that the table name, the variable that I have assigned my table, and this my table variable contains the values present against the cylinder along with the frequency in a tabular form, you can see. So let me confirm that all of you are getting the same output. Yeah. Okay. Yes, see here, this table, that means table is a command. Here you can see table is a command, and this command is will do what? It will store the values present against this variable, this cyl variable. The values will be stored in a tabular format, and the values, the whatever the table we have just formed using the table command, that will be stored in my table variable. So if I want to see the values present in this values present in the tabular format of the variable cyl, that can be viewed using the view command. So whenever you are writing view command, make v as capital, otherwise it won't show you anything. Okay, so are you all getting the same? Okay. So clear everyone? Did you get the same output? Okay. Am I clear? Okay, okay. Okay, no issue. See here, you can cut the table. That means the tabular value of the, that means the tabular format, the values again the cyl variable is stored in the tabular format. And you can also just cut the table. Just click on the cross symbol at the top, that means in the code editor section, and you will just cut the table, right? Okay. Okay. Next, you see. Next, click on this arrow mark where it is written go back to the previous source location. Click on that arrow mark and your code editor will be free. Okay, everyone getting the same? See that if I want to perform few additional operations, I need to install few packages, right? So whenever you will install packages, few means additional functions will be activated. So using that, we can perform various operations, right? So let I want to install a package. That package name is Shike, right? So whenever you will install package, you can see that whether the package is installed or not by clicking on the packages in the fourth panel. Okay. So in the code editor, just write install. Okay. It will come as install.packages. So click on that. Click on that, and I want to install the Psych package. Okay, so PSYCH. So this is the package I want to install so that I will be available. I will access few functions that is present in the Psych package, right? So here, just click on this. Click on this. Then click on run, right? So whenever you will just select that and click on run, wait for a while and the package will be installed. Okay. So now my package of PSYCA, that means Psych package is installed, right? So after installing a package, you must require it. Okay. Require it means we have to call the installed package and it will be available, right? So we can do what? We can write the command or write the function as require. It is coming as require, then within bracket the name of the package we want to call. The name of the package is Psych, right? So here, just click on this. Click on run. Okay, then it is written that Psych packet is loaded. So that means here the Psych package is loaded. To see the availability of package, so in the fourth window just click on the packages. Okay, click on the packages. So when you will click on the packages, you see there is a tick mark in the Psych package, right? Everyone, you are getting the same output. Whenever in the fourth panel you will click on packages, you will see the package Psych is installed and it is tick mark. That means now the Psych package is available for our use. Everyone getting the same? Okay. So first
Yes.
of all, in order, yes. So in order to use your package, you have to install that, right? So you can install that using install.packages. Within bracket, you have to name the package you want to install. So if we are installing a package, we can use various functions supported by that package. So after installing, just select that. If you are writing that in the code editor, select that and click on run. So after clicking on run, you have to wait for a while till the package is being loaded. So after installing a package, you have to see that whether that package is available for your use or not. So that you can see by writing the command or writing the function require within bracket the name of the package you have installed. So after doing that, just select that line require within bracket the name of the package and click on run. Okay. So whenever you will click on run, you will see the package site is loaded, and or any package you want to install that is loaded. You can also check manually by clicking on the fourth panel. Just click on the uh, um, uh, uh, packages in the fourth panel, and you see that the package you want to install, that will be tick marked, right? So if it is tick marked, that means the package is now available for your use. Okay. Okay, so this is the process by using which you can just install your package, install any kind of package you can install. Okay. Okay, let suppose I want to use a few, that means with statistical information. Let I want to just find the variance. I want to find the number of variables. I want to find the means the skewness or the mean, median, etc. of a particular data set, right? So we can do that in a particular command that is called describe, right? Describe command. So let me open the R Studio again. Here you can see, uh, let I'm writing iris. Okay. Then here this click on this iris. You can also control enter. Press control enter. You can also run without selecting, without clicking on run. If you are writing something in the code editor, just click on control and enter, and you will see the output is being displayed, right? This is one of the method. So if you are clicking on iris data set, that means you can see that in case of iris data set, the number of variables are here. How many number of variables are there? So you can see that the number of variables are sepal length, sepal width, petal length, petal width, and species. So it has one, two, three, four, five number of variables along with the observation, right? So I have to attach the file, the data set. So I have to attach iris, right? So click on this, click on, just select this and click on run. Okay, that means iris data set is now attached. So I want to describe, I will take a particular variable. So the values of that variable will be automatically inputted. Then after upon these values, upon the values of the variable, I can perform various mathematical operations through a single function that is called a describe. Okay, so if you write describe command and you want to find the mean, standard deviation, median, trimmed value, minimum, maximum value, skew value, kurtosis value, range, and the standard means error of a particular variable. So let, as I have five number of variables, let I have to find the I have to find the mathematical operations of sepal length, right? So just click on control enter, and you can see that the zipper length is a variable and it has number of values inside this variable, and upon the values you can find that it has n 150. That means the number of observations are 150, right? Variable is 1, we are taking only zipper length. Mean of the values is this much. Standard deviation of the values present against the zipper length is this much. Median is this much, and this skew and kurtosis values are 0.31 minus 0.61. That standard error value is 0.07. So what are these? These are the mathematical operations that can be performed on the values. These are the mathematical operations performed on the values stored against this simple dot length variable, right? And how can you get that? We have to write the describe command. Okay. Okay, are you getting the same value? Okay. See, you know everything now. You know standard deviation, you know mean, median, trimmed value. Yesterday we discussed that is 0.1. That means 10% on the above and 10% on the below. That means the extreme values you have to trim and 80% you have to take if you are taking the trimmed value of 10%. Okay. So this median, mean, max, range is what? The difference between max and mean. And the skewness is what? Skewness and kurtosis value, these are used to quantify the shape of the distribution. That means whenever we are taking the values of a variable and we are just plotting the values, so the shape of distribution can be quantified by this skewness and kurtosis value, right? So here what this say skewness means it can be symmetrical, it can be non-symmetrical, right? So symmetrical skewness means the values are distributed in such a way that mean value is equal to the mode is equal to the median for the values. That means you have studied in the bell-shaped curve, right? So at that kind, at the top, the mean is equal mode is equal median. So if this there is this kind of distribution of the values, so we can say that is symmetrical skewness is present in the data set, right? Non-symmetrical means it can be positive, it can be negative skewness. That means if you are taking at the positive skewness, right hand side value, that means the values are distributed in such a way that whenever you see the plot, the right hand side values will be greater. The skewness will be more at the right hand side. And if you considering the negative skewness and the values are distributed in a graph, then the left hand side values will be skewed, that means more skewed than the right hand side. Okay, so this is called skewness. And what is this kurtosis? This is the extent to which the frequency distribution is peaked, okay, in comparison with a normal curve. That means it will be compared with the normal curve, and you will see that up to which extent the frequency distribution is peaked. So this is all about skewness and kurtosis. So you do not have to calculate by your own. You have to, if you are using R Studio and if you have a data set, you can use the describe function to find all the mathematical functions. Okay. And this describe function is available in the package Psych, right? So that's why we have to install the Psych package. Otherwise, we cannot use the describe function and we cannot get these values present. So, up to this, anybody, any doubt? Are you getting the same data, same output? Let me confirm first. Then, any doubt you want to ask me anything? We are getting different output. Yes, yes, yes. See, yes, yes, see. That we are from yesterday till today, we are just working on the data set already present, right? So we can also uh, work upon the data set that we are storing. Let you are working in a company and you have stored the data that you have collected. Let you have collected data for 1 month or you have collected data for 2 months. You can store that in any file format, right? Any file format. You can also import. Okay, after just finishing the how we can work with the sample data set, I will tell that how can we import and how can we work if we have stored data manually at any point, right? So we'll discuss upon that. Here only that I told yesterday that First of all, we'll discuss that how the operations can be performed on the sample data set that is already present. So after finishing that, we'll discuss that if we have stored data at any point in our system, at any place, the number of data set, then how we can work upon that. We will perform all the hypothesis analysis. If we will perform the cluster analysis also, we'll perform the correlation also. Okay, so don't worry about that. I will discuss. Okay. See here, it is one. If you can see Sylvester, this R Studio, suppose you have stored the data in the Excel, if you have stored in the database, if you have stored at any place, or if you have data stored in Excel and you have converted that to CSV, so they are these are the these are the when you will click upon this, you can also import the data stored at various places. Okay, you can directly import by clicking on this. Okay, this is one of the option. If you're not just obtaining this import menu, you can here also you have to write read. Suppose you are just stored your data in the CSV file, you can use read.csv function. If you have stored in the Excel file, you can write here read underscore Excel function using the various command. There are so many commands we'll discuss later after finishing the sample data set work. So using that, you can also import the data stored by you. Or if you have collected data manually, or if you have collected data from somewhere and you have stored data, then those data can be implemented in R. So R will consider all the data that is already present. And if you are giving some data sets by your own, it is compatible in both the cases, right? So once it will take me 1 to 2 classes to cover all the means the topics that is related to R, that clustering, how we can form clusters, how we can form data reduction, that we have covered in the theory section. So after completing, I will just inform you that how can you import the data set created by us. Okay, and the data set upon the data set that we have created, we can perform various operations. Okay, so don't worry, we'll discuss. Okay. Yeah, all the doubts you have, I will clear one by one. I will clear. Just wait that I am just teaching on the sample data set. After that I will go for the data set created by the user. Okay, Sylvester, any doubt you want to ask me anything? Clear, na? Clear, you are clear. Yeah, yeah. Just wait. That today I will take today's class, and tomorrow also. That after that I will just say to everyone that how we can import, how we can use the if we have stored, created a data set by our own, how we can use that and how the various operations will be performed. Right. So at that time you will just see how the working is going on. Then if you feel any kind of difficulty, you can ask me. Right. Okay. So am I clear to everyone? Regarding up to the operation that I just told about in our studio, that we are performing various operations, right? So everyone is clear. Any doubt you are facing? Okay.
No doubts.
Okay. See, next you see that okay. Next, you see that just clear your code editor, clear this, then clear the console. How can you clear? That is Control L. So your console will be clear. Then what you will see that in the console, right? Again, we have to perform other operations. Okay, other operations. How we can plot? Because in our theory section we have studied about data visualization, right? So we have studied scatter plot and how we can plot, and here we'll see any other plots, right? So let I'm taking the data set of this data set of iris. Okay, iris data set. You know that how we can just use the iris data set. So yesterday we are using the iris data set. Today also I gave the example of iris. So here again, let I am just considering the iris data set, right? Then click on this, right, again iris data set. Okay, here click on this. Okay, that means when you will click on this iris data set, you will get these informations, right? So iris has 5 variables. In the global environment section also, you are just showing the same, that iris data set has 5 variables. That means 5 columns it has, and it has 150 observations. Here you can also see, or you can also count by your own. Okay, in the right hand side you can see the third panel, environment panel. So it is showing that iris is the data set. It has 150 observations and 5 variables. You can see 1, 2, 3, 4, 5 variables are there. That means 5 columns and 150 observation total. So it is up to this, it's okay. Then what we have to do? We have to attach, right, this iris. Okay. Then click on enter. So whenever we are attaching, it is showing that it has petal length, petal width, sepal width, and species. So these are the objects that is related to the iris dataset. That means this is attached properly. Iris dataset is now attached. So that's why it is showing that it has these variables or these objects. Okay. So after this, what we'll do? Suppose I want to display the values stored against a particular variable in iris dataset in a graphical way. So how we'll write? Let I want to form histogram. So I will write the function as hist. Within that, I will write let sepal length. Okay, simple length. So then click on enter. So whenever you will click on enter, at the right hand side in the fourth panel you can see the histogram is written. Okay, histogram is displayed, not written, displayed. And just it is showing the values, and the how the plotting is there, because simple length has simple length considered of various values, and according to the values the graph is plotted. That means histogram is plotted. You can zoom it also to see. Okay, sepal length and frequency. Okay, these are sepal length and these are the frequency. And it has anonymically written the title of this histogram, because we have not given the title of the histogram. So it has arbitrarily taken the title. Okay, so if you want to give the title, if you want to give the name of the x-axis, name of the y-axis, that as we know we can also give. So let we'll do perform one by one. So we'll write hist function, and within that click on this hist. Within that write sepal length and bracket call. Call is a parameter used to color the histogram. Let I want to color this as red. Okay, so click on enter. You can see that the change the means the histogram is changed to red color. Okay. Okay, so further improvement, all of you are getting the same output. So run along with me. I am just executing, you also execute at the same time. Okay. Okay. So further improvements we can also do. Further improvement means we have just taken the value. That means the value we have to taken. We have to take the value stored against this simple length variable, and color we have taken as red. We can just give the title of this histogram. We can give the name of the x axis, y axis also. Okay. So here I can write let hist function is here, then it is written as simple length. Let the same thing I'm writing here. Curl is equal green, then comma, separate the parameters using comma, main. Man is a parameter. It is used to give the title of a chart. Let this is histogram and separate with comma, write x lab is equal sepal length y lab is equal count. Okay, and another thing is that it is breaks is equal, let I am showing as 9. Okay, so let me just explain what are the parameters and what is the values. So here hist function or hist command is what you want to form the histogram. That's why you are using hist method or hist function or hist command, right? So the values you want to form histogram of the values present over sepal dot length column. Okay, so the values present in sepal dot length variable you want to form the histogram. So color of the histogram will be green, its title will be histogram, and x-axis title will be sepal length, y-axis title will be count, and here breaks is a parameter. Okay, so before equal what the things are written, those are the parameters. So call is a parameter, main is a parameter, x lab, y lab are the parameters, breaks is also a parameter, and after equal what is written, that is the value against the parameter. So if here I am written as green, that means this is the value of call. Histogram, this is the value given to main parameter. Sepal length is a value given to y lab. Count is a value given to y lab here, and 9 is the value given to breaks. Okay, so what is breaks here? Breaks is a parameter, it will change the number of bins. These are the number of bins, right? And but not necessarily it always it won't work, it may work or it may not work, so it depends. Okay, so don't just think that if I've written breaks is equal 9, that means you will get 9 bins. Okay, it may happen or it may not happen, so it is not necessarily change. So when you will just click on this, click on enter, you can see the this thing is happened. That means all the commands or all the parameters are now applied to this sepal length. Okay, so are you getting the same? Okay, same output everyone is getting, right? Okay, did you understand the things that I've written here? Okay, no issue at all, everyone is clear. Okay, see, this is the histogram, right? We can have the box plot also. So how we can do that? You have to write the command box plot. Okay, box plot. Then within bracket write sepal length. Suppose we want to display the values present in sepal length in the box plot format. So when you will click on this, click on enter, you can see the graph shape is changed. Now it is showing in the box plot diagram. Okay, you can also change the color. How we can do that? You can also name the uh, chart also. So I can write here the further refinement, that if I'm writing here box plot, and here I'm writing sepal length bracket call is equal. Okay, let I'm changing the color to green, and main is equal, let I'm giving the title of the graph as box plot. Okay, so click on this, enter. Okay, now you can see that the box plot color is changed, it is now converted to green, and the title is written as box plot. Okay. So this was a histogram. So how we can do the scatter plot? We have studied yesterday that using plot function you can get the scatter plot. That means that will be points. The points will be stored. So you can just change the size of the points, or you can change the shape of the points also. Right? Okay. So everyone getting the same output. Okay. Any doubt? You want to ask me anything, or am I clear to everyone? Yes. Please write. I'm not getting your sound. That means your voice is breaking, right? So you are not properly audible. So please write your query in the chat box. See, this is your question. Okay. See, that means your data set, you can see that data set. Suppose you are working in a company, like you are working in a company, you are working on a project, right? So, whenever you will just collect your data, okay. So, what we have studied that whenever you will collect your data and make sure that there is no anomaly in your data set, right? So that means the data you have collected should be proper, should be accurate one, and that shouldn't have anything that will affect the output. Okay. So at the time of data collection, if you are suppose you are using any kind of filters in the data set, you can that will just make you clear that your data set is perfect. This R is what we are using this R Studio to do further analysis on the data set you have collected. Okay, so first of all, you have to collect the data properly. After that, you can do further analysis using R Studio or any other means softwares we can also use further in during the practical session. I will just say that using those means software, using those tools, you can just do the various analysis on the data set. But whenever you will collect the data set, make sure that you are collecting the proper data set without any biasness. Because if you select the data set with you will select the biased data set, that may hamper the result you will get. Okay. So if the data set, the sample you are collecting, that will be biased, then it will just hamper the entire data set, right? So make sure that your data set you are collecting should be proper. That means shouldn't have any anomaly, shouldn't have any error. It should not be biased, and it shouldn't have any null value because it will affect also. It shouldn't have any means you can see suppose duplicate data sets are there, right? Or duplicate data values are there, or if in one column you are just putting number of values against a particular column, that is also a confusing one. So don't make your data set so confusing that the software you will use that won't recognize your data set. Okay, so make sure that you are collecting the data set in that way. Okay. Okay. So am I clear, Sylvester? Okay. Thank you so much. Next, see. Okay, so now we'll discuss about Pearson correlation in R. Okay, in R means you have to use the R Studio. We have to write the code based upon R language, and we'll find the Pearson correlation. So correlation means how the variables present in a data set. Let we are using the sample data set. Let we have created a data set. We want to use that. So what is the relation, how the variables are related with each other, that can be analyzed using this R code and R Studio, right? So we'll do the analysis that how we can find the correlation among the variables, right? So here what you will do, that go to the code editor portion. Here you just clear the console, right? So control L you press and the console will be cleared. Then go to code editor. There you write data. That means say the data set we want to find, let it is iris. Okay, we'll work upon the same so that it will be clear to all. So data set is iris. Then here what we'll do, that we'll write this iris data set. Okay, so whenever you just click on these two, select on these two and click on run, you can see that the iris data set is now displayed. Okay, now displayed. Here what we'll do, that you have to attach the data set. So attach, within bracket you have to write the data set you want to attach with R Studio, so that is iris. Then just select this and click on run. Okay, so when you will run, you can see that these are the variables or the columns that is being stored in the iris data set. So it is now displayed. That means your iris data set is now properly attached. Okay, so you can find the structure of iris dataset using the str function that we have discussed. We do not need to write again. So str function or str command, within the bracket you have to write the data set and you can find the structure of the iris dataset. Okay, so next we want to find the correlation among petal length, petal width, sepal width, or petal width, sepal length, or species along with the petal width. Okay, so we want to find the correlation, how the variables are related with each other, positively increasing or negatively increasing, or if the variables do not have any relationship with each other. So we can find the correlation analysis. So how can we do that? Let I'm just writing a variable b, and within that I'm writing core dot test. Okay, core dot test. So here core dot test function will do what? It will perform the correlation among the variables present in the data set. So I will do what? I want to find the correlation among the variables present in the iris data set. So I will write here iris. Okay, then square bracket. So how many columns I want to take? So I suppose I want to take the columns from 1 to 4. So I do not want to take the species because there is nothing written in the species. That means it is written in string, na? So that we cannot compare. So petal length the values are given, petal width the values are given, sepal length, sepal width the values are given, right? So we can just compare the correlation, find the correlation between the among the values. So we have to give 1 is to 4. Okay, 1 is to 4. So here what we'll do, then write here print b. Okay, b. Then we'll do what? Select these two lines, click on run. Okay, so when you will click on run, you can find the correlation matrix here and the probabilities values. Okay, so let me explain again these two lines. So core dot test is a function that is used to find the correlation among the variables present in a particular data set. So we are considering the data set as iris, and we are considering the variables from 1 to 4. That means first is sepal length, second is sepal width, third is petal length, fourth is petal width. So you can see in the output that the correlation matrix of variables from first to fourth number of variables are only shown. Fifth number variable is discarded, right? So the value is now, the value of this right hand side is now stored in the left hand side variable. That means it is stored in B. So if we want to know what is the correlation matrix among the variable, we can print this B so that we can get the value. Okay, so this is the correlation matrix and the probability value displayed at a time. Okay, so if you need the, you can see here, you can see that, see, whenever you are looking at this correlation matrix, you can see the diagonal elements, right? 1.00, 1.00, 1.00, 1.00. That means correlation matrix will be shown, and you can see that the diagonal elements will start from 1, because correlation matrix is a symmetric one. The diagonal elements will start from 1, and you can see here minus 0.12, here minus 0.12. This is 0.87, this is 0.87, this is 0.82, this is 0.82, and this is minus 0.43, this is also minus 0.43. That means we can see that the correlation matrix is symmetric in nature. And in case of correlation matrix, whenever you find the correlation, the diagonal elements will start from 1. So whenever we will just write the chord test function, you can get the correlation matrix also. Okay, so we can also have it separately. Okay, here we have written that correlation matrix is shown and probability values are also given. We can have the values in separate also. So how we can have, if I'm writing b here, the values of the right hand side, the correlation matrix values of iris data set of the variables from 1 to 4, everything is stored in b. So let I want to find the correlation only. So what will write? B dollar symbol R. Okay. So here R. So whenever I will just press Control Enter, I can have the correlation values or correlation matrix is being displayed, right? So if I'm writing B dollar, this is T. T. T stands for T test. Okay, you know that if the mean of the samples is less than 30, we can perform the T test. Okay, so whenever you will find the mean of this sepal, that means sepal length, sepal width, petal length, and petal width, if the mean is less than 30, that means we can perform the T test. So if you will perform the T test and will get the result as, this is the T test result. That means sepal length to sepal length, the test is infinite, because we cannot find the T test on a particular, on a variable by its own. So the T test of sepal length and sepal width is this much. The T test of sepal length and the petal length is this much, and the T test of sepal length along with the petal width is this much, right? So these are the value that is showed that we are performing T test on the variables, on the values stored in against the variable starting from 1 to 4. That means sepal length, sepal width, petal length, and petal width. We can get the T test value, right? Here another one, we can have the p value also. So let I'm writing here. Okay, in the code editor, write b dollar, then p p value. Okay, p value, you know that during theory class I was saying that if you know the alpha value, okay, alpha value, and if you know the degree of freedom, I also explained at that time, just showing you a table that it is stored that if the alpha value is given and you are getting the degree of freedom, then using the table you can find out what is the p value. Okay, so if we want to find the p value of the correlation matrix of the values present against the variables in the iris data set, I can have control enter, then I can get this the correlate the p values of this sepal length and the sepal this is given, sepal length and sepal width this is given, and sepal length and the petal length the values are given. See here, if the p value of a sepal length and sepal width, you can see here, this is the sepal length, this is the sepal width. We are finding the p value, and the p value is this much. Okay, so that means e to the power minus zero 0.1. So if you find the value, that will be approx 0.1518. That means the value of p will be greater than 0.05, right? So the interpretation says that if the value of p is greater than 0.05, that means the p value is non-significant. Okay. If the p value lies between 0.01 to 0.05, it is significant one. And if the p value is less than 0.01, it is highly significant. Okay, highly significant means there will be 3 star, and significant means there will be single star, and non-significant means there will be no star. Okay, so how can you find out the p is significant or non-significant? That if you have to taking this p value here, e power minus zero 1, you will calculate using the calculator, it will give you that this is approx 0.1518. Okay, you can calculate that like e point minus 47, that will be approx 0 something less than 0.01. Okay, you can calculate by your own. You can see that e power minus 47 will be less than 0.01. That means it is significant. Okay, so if the p values lies between 0.01 to 0.05, it is significant one. That means the analysis is significant one. If the p value is greater than 0.05, it is non-significant. If the p value is less than 0.01, it is highly significant. Okay, so we are just find out the p value of this one is sepal length between sepal length and sepal width. So this is the p value between sepal length and petal width, and this is the p value of sepal length and petal width. Okay, so these are the values displayed here. So are you getting the same output? Okay. Okay. One more interesting thing, that suppose I have I just received so many outputs of the correlation. Okay, I want to store these outputs in a particular file. Okay, how can you do that? You have to use this sync function you have to use. Sync within bracket, you want to give the name of the file where you want to store the outputs. Let the file is correlation on. Suppose you can give the name of the file as anything. Dot. This is dot doc. Okay, so I want while teaching means suppose I am just teaching you that these are the value that you can receive after the correlation analysis, and you want to store the all the output in a document file or in a word file, etc. Then you have to name the file. So let I have named the file as correlation on, and dot doc. Okay, doc is the extension. Then you have to do what? Select run. Okay, then you have to print b. Why we are printing b? Because everything is stored in b now. Okay, so print within bracket b. Okay, then select this, click on run. Again you have to close this sync function. We have just initiated the sync function, we have to close the sync function. So how can you do that? Just write the sync function. Okay, so select this, click on run. Everything is now done. So you want to check that whether all the values, all the outputs are now stored in correlation on file or not. Okay, how we can find out? Just click on files here at the fourth panel, click on file and just scroll down to check your file is present or not. Okay, here the file is present, right? Correlation on the file is now created. This is the doc file. Just click on that. When you will click on that, you can see that everything is shown here. You see the correlation test on the Irish data set. We have taken the variables from 1 to 4. This is the matrix. Okay, probability value. It has 150 observations, right? So, okay. So, are you getting this same output? You are not audible from the beginning, right? Sylvester, you are not audible at all. I can't hear you properly. Volume is very low. Okay. 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 Everyone clear? Let me check. Just I will just stop sharing my screen. Please, anyone of you share a screen that I can see what you have done. I'm just clicking this, just waiting my sharing of screen. Just any one of you just share your screen. Any one of you just share a screen. Okay. Did you get correlation? Okay. Did you get the file? Check in the fourth panel. Check in the fourth panel. No, no, fourth panel. Yes. Scroll down, scroll down. Click on the files. You have clicked on the files. Scroll down. Yes, click on the files. Okay. Scroll down to check whether this is present. You have written correlation. Yes, yes, it is present, right? Click on that. Click on that. Word file will be opened. No, it will come automatically. Do not need to close that. Again, click on that. Okay, it will be opened in the Word file, right? Yeah, yeah, yeah. Everything will be shown, right? Okay, 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 okay. Yes, yes, yes. Okay. Next, see. Let me share the screen again. Okay, okay. Now it is my screen is visible to everyone, right? Okay. So what we'll do? Okay. See, go to the plot in the fourth panel. Go to the plot file. Here you can see this is the clean option. Okay, this is clear all plots. Click on this, and your the plots you have done that will be clear. Okay, just clear the plot section or the fourth panel. Okay. So here what we'll do, let I want to display. I want to display the values stored in the variables from 1 to 4 in the iris data set in a tabular in a graphical form, right? So for that I will write the function as pairs dot panels. Okay, pairs dot panels. Okay, within that I have to write the data set, that is iris data set, and I want to take the values, the variables from 1 to 4. So either I can write 1 colon 4, or simply write comma, then write minus 5. Okay, this is also one of the method. You can write 1 colon 4, that will give you the variables from 1 to 4, or simply you can write comma minus 5. Minus 5 means it will discard the fifth column, and it will consider the values, the variables from 1 to 4. It will discard the fifth variable, right? Then I want to write PCH. PCH is equal 21. Okay, so PCH is what? There were two parameter, that was CX and PCH, right? CX was for to increase the size of the plot, okay, and PCH was just changing the shape of the plots, right? So PCH is equal 21. The value was from 0 to 25, if you remember from the yesterday's class. Then I have to write the stars. Stars is equal true. That means T. That means here, whenever you will run this, you will get some output. Let me check you. Here, just click on Control and Enter. You can see the output. You can zoom it out and see the output. We have written stars is equal capital T. Capital T means true. That means we want to include star in our diagram. So you can see that 0.87 triple star, 0.82 triple star, minus 0.43 is triple star, minus 0.37 in triple star. So if we do not want to enable star, that means we do not want to show which one is more significant. We can also write star is equal false. Okay, so this diagram you can see, just see what is there. Let me increase this. This is the entire correlation diagram that is shown in the form of graphical representation. So the correlation among the values stored in the variables, that is sepal length. These are the variables, right? 1 to 4, because we have discarded the fifth variable. So sepal length is first, this is second variable, third variable, and the fourth variable. So this is the entire diagram. This diagram can be obtained through pairs dot panels function that is present in the R studio, right? So this is what, try to understand this diagram. So these diagonals, this sepal length, sepal width, petal length, petal width, these are what? These are the distribution of the values present in the variables. Okay, so these are the graph is what? These are the distribution of the values present in the variable, right? The diagonal one. And here you can see this is the scatter plot, right? This is the scatter plot. And the scatter plot, this shows the distribution, or you can see the graphical representation of sepal length and sepal width. Okay, this is the scatter plot between sepal length and sepal width. This is the scatter plot between sepal width and petal length, right? So this is the scatter plot between sepal length and petal width. This is the scatter plot between sepal width and petal width. You can see this is the scatter plot between petal length and petal width, right? So these are called the scatter plot or diagrammatical representation of the values present against the variables, these four variables, right? And this is what? This is the p value. P value of sepal length, sepal width. This is the p value of sepal length and petal width. This is the p value of sepal width and petal length. This is the p value of sepal length and petal width. Okay, so in this way we can find out. That means we have just displayed the p value and the distribution of the variables present in the data set and the scatter plot. Here triple star means most significant. That means if you find the p value between sepal length and petal width, the 0.82, that means it is the most significant one. If it has not associated with any star, that means it is non significant. Okay, so if there is no star, that is non significant. If there is single star, that is significant. And if there is triple star or double star, that is highly significant. Okay, so this p value is highly significant if we have associated with the stars. So how we can just input, or how we can show our graph? The p value will be displayed in the with star format. If we are writing the stars parameter and we are making it as a true. Okay, so if you don't want to associate the values or the p values along with the star, you can just write stars is equal false. Okay. See, one more thing, that suppose you are clicking on this zoom, right? Clicking on this zoom, but it is not, that means your graph is not zoomed out. So wait for a while, it will be, oh, okay, okay. See, suppose you want to store this, the diagram in any format, you can just export that. You can save as image, you can save as PDF also, you can copy to the clipboard also. So these are the options that is available in the fourth panel in the export menu. You can save your diagrams in image format, PDF format, or you can copy to the clipboard. If you want to cut, you can click here, or you can just click on this to clear this diagram. Okay. Let me introduce about this pairs.panels. What is that? See, that pairs.panels is a function that is present in R. It is a function in R. So it can be utilized if you have installed the package Psych. You remember one thing, that we have installed the Psych package, right? So Psych package provides few, means we have installed in the purpose that we want to use some functions. So after installing the Psych package, we used describe function, we used pair.panels function. Okay. So what is the purpose of the pairs.panel function? You can see here, pairs and panel function. This can create the scatter plot matrix. We can see the scatter plots, right? The scatter plot matrix with the enhanced feature. That means it can see, it can show you the p value, it can show you the distribution of the variables, it can show you the scatter plot. So generally it is used for the data visualization. So if we are using pairs.panel, we can use, we can have the data visualization before us, right? So for that, we are using pairs.panel function, and this function is present in Psych package, right? So here you can see that we have installed Psych package. So you can see here also Psych package is installed and it is tick mark. That means now Psych package is available for our use. So that's why we are using the pairs.panel function. We can make use the describe function, etc. So we have installed Psych package. Suppose I want to uninstall or unload the package. Okay, so how we can do that? You can write the comment as, uh, I want to unload. Let unload Psych package. How can you do that? We have to write the command as detach. Okay, detach, within bracket. You have to write within double quote, package colon, which package you want to detach, that is Psych package here, then comma, unload is equal true. Okay, just click on control enter. Okay, so when you will click on control enter, you can see that it is written that Psych package is detached. Now, how we can see